Now let's take a closer look at the idea of total distance traveled relative to displacement. So in the previous example or previous question, it did ask for the displacement, right, of the particle that was moving horizontally between t equals 0 and t equals 3. So the idea was that obviously I landed, right, I started here at t equals 0 and then I landed here, right, when t was equal to 3. But in between, there's no telling, right, what I was doing. So the displacement is still 3 meters, but I have no idea exactly what was going on in between. I could have gone well beyond 8. I could have just traveled straight from 5 to 8. I just don't know. So as far as the distance traveled goes, we're going to have to take a look at where the velocity is equal to 0, because we're going to have to look at turning points. We're going to have to look at these places, right, of where my particle changed direction to determine if my particle changed direction at all, to determine how much distance the particle actually covered. So let's make a note here, right? So different than displacement. It's really important that we grasp the understanding but that the displacement and the total distance are not the same thing. They are not measuring the same thing. It's important for us to understand that with particle motion. Total distance means we must check turning points. I'm going to call them turning points, but the idea of the particle changing direction. All right, so I'm still going at, I think, end points, right? So I'm still headed down this path of I want to know the position at 0 and I want to know the position at 3. We already figured that out. So the position at 0 was 5. The position at 3 was 8. But the question is, what was the position at 1/3? Because that, the 1/3 and the 2, right, that is where the velocity was equal to 0 from part B of this example. So I need to know the position there. So I'm going to use my calculator for this. So I have already put the equation for position into my y equals. So I took y equals, I plugged in the equation for position. Now I'm going to use the alpha F4 feature. So alpha and then trace, right, which is calculate F4, and that gives me a list of all of the different y functions that I could be using. Well, I put my equation in y1. If I want to substitute anything into y1, I just put it in parentheses. As long as I put in parentheses, it will do the subbing for me. So if I want to put 1/3 in there, I'm going to get my position to be 5.6296, etc., right? And then I'm going to repeat the process, y1, and I want to plug in a 2. I could have gotten the 2 from the table pretty easily, but obviously the 1/3 I could not have gotten from the table. It would have taken me to change my settings of my table for me to figure out the 1/3. I would have had to gone in and do something a little different there. But I don't want you to hand plug in values over and over and over again into these polynomials. I want you to use the calculator efficiently. So now that I have these values, I'm going to say S of 1/3 was 5.6296. I'm going to go ahead and round to 4 decimals. And then S of 2 was just 1. So the idea is that I want to look for the change in position between each of these. So from 5 to 5.6296, obviously I went right 6296 units. In this case, we're dealing with meters, but that's how far I traveled to the right. But then I went back left, right? I went left 4.6296 units. And again, we're just looking for the difference, right? So as long as I subtract, I'm going to be able to get the right answer. So this minus this, this minus this. Okay, so that's what I'm looking to do. And then I've got 8 minus 1, which is, of course, I went 7 units back to the right. So now what I want to do is I want to consider that this is total distance, which means the direction that I traveled really doesn't matter. I'm treating everything as positive here when I deal with total distance. So total distance has to do with the absolute value. So total distance, let's put a note, include absolute value. Right? I think it's important to recognize that we may be going different directions. So total distance equals 4.6296, absolute value, right? Plus the absolute value of negative 4.6296, because I'm basically going to treat that as positive, plus, now obviously I didn't have to have absolute value signs for this first term or the 7. They're already positive. But indicating that you know everything should be positive is very important to this process. So I'd like for you to go ahead and include that here, even though mathematically it's not going to change my answer. So then once I get all of that, I just need to put it in the calculator, right? So I'm going to end up with 12.2592, and then I'm going to go ahead and make sure that I attach that unit correctly. So that is the total distance traveled, which is very different from the displacement of 3. And it's because I went forward a little bit, but then I went all the way back to 1 and then back to 8. So I had to include that piece in this total distance traveled process.